is all too common a response I hear when I go to these DevOps, CI, CD talks, see videos online about how you do CI, CD for databases. CI, CD has largely been sort of the world of the developer. Databases, they've felt, been too difficult. My aim today is to show you that it is possible and how in conjunction with Azure, you can build a very secure, compliant process for your database delivery. My dream is that everybody is able to deploy databases at will as much as you need. The one thing you'll have seen over the past few days and build last week is this need to go and push software very quickly. The whole agile delivery, fail fast, get things out quickly. The big challenge is that many DBAs think it's not possible. You look at some of the tooling, some features aren't lit up in the tooling, which makes it very difficult to actually do this. It doesn't have the sort of classic Microsoft stance of it just works out of the box. So you have to work at it a bit. I want to show you it's possible. But probably the biggest thing is fear. I find that I speak to DBAs and they go, I can't do automated deployments. I need to review stuff. I need to control stuff. It's my domain. I'm the guardian of this data. How can I have a developer push a database change through to production? There's also the fear of, from an Azure perspective, putting your database in the cloud, putting your data in the cloud. What I'm going to show you today is that Azure DB and Azure in general is probably more secure than most of your on-premise and hosted systems you've currently got. My name's Simon Sabin. I've been working with databases for about 20 years. And I've been deploying and building deployments of databases from day dot. I'm a guy that doesn't like to do things twice. I also don't like to do things manually. If you give me a checklist of things to do, I want to automate it. And that's what I want you to be able to do. My focus is on DevOps, but with a database function. I always feel that there's this dev-DBA divide. That shouldn't exist. As data people, you are the data specialist. You understand data. You understand some of the security aspects. But devs are building the systems. How can you work together in a DevOps world and build and deliver systems reliably and efficiently? So today, what I'm going to go through is what CI, CD, there's two CDs to confuse things, what they are, how they work with compliance. Can you do CD in a compliance world? You have your auditors that are saying you want to do X, Y, and Z. Can you do CI and CD in those worlds? How does that work with Azure? And then finally, we're going to go through a nice big demo of how you can actually do the impossible and do very complicated deployments of databases using the tooling that is available to you today. So first of all, let's kick off and let's create a database. How many of you are, would you class IT pro, IT manager type style people? Okay. DBAs? Developers? Okay. How many of you are already doing agile development, CI, processing? Okay, quite a few. And how many of you are doing database deployments with that? Interesting, yeah. Probably about a third of people that are doing CI don't have databases included. That's actually quite a high percentage. What we have here is SQL Server Data Tools. SQL Server Data Tools is essentially the database part of Visual Studio that allows you to model a database and deploy it to a server and fit it into your normal CI source control process and your build process. I'm going to finish off creating this table. And what I've got is I've made this change. You get a nice combined editor here. So if you want to do code, you can write code. If you want a designer, you can use the designer. And you get a nice summary of the table here. So we've got some indexes. And importantly, something that's often missed is you have your permissions. So I'm going to go and check this in. A new table. And then go and sync this and push it up to my server. So I'm using VS Online. How many people are using TFS? Okay, quite a lot. So this is using VS Online. And if we look at my builds, I should see a new build has come in. If I go to Management Studio and I refresh, then you'll see, that's because I had a database before, there's no databases in either of my systems. And what I have here is 2 Azure SQL Azure servers, a dev test one and a production one. Why have I got 2? Because I can nicely separate my responsibilities, security, firewall settings, so that I only have dev and testers talking to my dev test servers, and I've got production being isolated. So even in Azure, you can do that very easily. What I then have is Release Manager, which is taking my builds and pushing those builds into my Azure environments. If I refresh, the build should have triggered off a new release. And that release will be, first of all, deploying to my dev environment, and then it will be going off and deploying to my production environment. So you see here, I've got a set of dev steps, and then I've got a set of production steps. So that's me creating a database. So we'll leave that running, and we'll carry on with the presentation. So what is CI and CD? So CI consists of continuous integration, and then CD, continuous delivery and continuous deployment. Now, it's just about automated deployments, isn't it? It's not. Yeah, I've been doing automated deployment for 15 years. I've had scripts that enable me to create a database from scratch for a long time. What this is about is having it an integrated, continuous process from which you make a change, you check it into your source control system, that combines those changes in a continuous way to push it through your environments. So continuous is all about always doing this process. One thing I find from a database perspective, so being a data guy, DR and HA is a big part of what I've done historically. What I've always found is that people have had a DR process that runs, and they do it every 6 months, maybe every year. They test it out. Now, the problem with that is that it's a bit like your tax return. You have to go and fill your tax return in online nowadays, but you only do it once every 12 months. And you get to that 12 months, and it's like, what's my password? Because you don't do it all the time, you forget how to do it, you don't forget where to get the forms, and it becomes a very onerous process. So doing it continually means that you iron out all those little things that cause problems, and because it's continuous, it's familiar. And so you're always getting things done. if you're working in an agile development practice, then you need to have a continuous process. Otherwise, you can't get that fast feedback, and you can't then iterate quickly, and your developers can't go and make those changes and understand whether something works or not and iterate over your code. So the integration piece is very much about bringing those code changes together that the developer's working on, building an application, combining those applications so that they integrate together and go and be able to deploy those into multiple environments. Devs are if you're writing code, you can write unit tests very easily, which don't necessarily need you to do a deployment. However, with a database perspective, you generally have to do a deployment to do your testing. Yeah? It's very difficult to go and run a pseudo database and run mocks and all those sorts of things without actually having a database. So there's some things about local DB which allows you to spin them up easily, but you still have to have that ability to do the deployment and make changes to your database structure. The deployment becomes critical. So the deployment is about the ability to, once you've got those changes combined, to deploy those and make those changes to that database. And so I'm sure you've all been through this process and seen these slides before. Dev writes some code, checks it in, and that then runs some tests. Those tests can then result in a build, which then means you can deploy your code and eventually also to deploy to production. That deployment needs to be automated. Otherwise, if you're looking at the new development practices, how many people are writing service-based applications? I mean, if you look at the API models and all these microservices, nanoservices that are being talked about, you're talking about very small units. And those small units need to be deployed. And so you end up with lots of these. And so if you don't have automated deployments, it becomes very, very difficult. Until recently, I was working at a company full-time, and I class it as a modern development company. We were building microservices. We had lots of them. So we had about 30. We had about 40 different services, each with a database. And then we had those 40 replicated in different solutions. And so we had about 6 of those solutions. So that's 240 databases. And then we had about 5 or 8 test environments. So you're looking at a very large number of databases. If you're not automating the deployment of those, you're going to have a problem. You're going to have the ability to iterate fast on your development process. Now, that's your test environment. But what becomes more important is actually your developers. We had about 250 developers. 250 developers times 40 databases, that's 10,000 databases that need to be managed from a configuration perspective. If you're expecting DBAs to run scripts, it just doesn't work. Yeah. We actually got to the point that we were running about 2,500 database deployments a day. Some of them were noddy, yeah, adding a column, changing, renaming something. But it meant that a developer could make a change, check it in, run some tests, and got that fail-fast process, got that feedback very quickly, and got that back into their development process. But you say, how does that fit when a DBA needs to review changes? The DBA needs to check stuff. Also, the DBA needs to do the deployment. They're the guardian of those databases. My answer is, really? Do you really need to do that? I mean, not many DBAs in here, so I'm probably not going to be shot for saying some of this stuff. But I think this is what I'd like you guys to take back is, what does the DBA reviewing stuff need to do? I mean, are they reviewing standards, code standards? Are they reviewing naming standards? Are they checking formatting? What are they actually doing? Are they checking your business functionality? Now, if you're working in teams, and I mean, so many times I see this where you've got a developer team and you've got a DBA team, and the developer team has a nice backlog, works on a feature, and then has to pass the code over to a DBA team to go and review. And it's like, so what are these guys going to do? They can't check the functionality of your code because they weren't involved in the sprint design. They don't know how things should work. So they can't really check it functionally. So what are they doing? Are they checking things from a performance perspective? Well, okay. They're the subject matter experts from a database perspective, so maybe they are checking and able to do that. But my view is that if they are doing that, then you've got a big blocker in there. You've got a big roadblock. What you should have is performance testing in your pipelines so that the people that are pushing and making the change are empowered to understand that change and review that change and have the testing in place that means things are captured. I'm fascinated to see the change in how Microsoft are delivering software lately. In the past 2 years, it's just changed, gone over it on its head. They have these small teams and they can iterate fast. And that's because the teams take ownership and have the empowerment to own and what they deliver. Sticking a DBA in the process is just a massive roadblock. So if you had a dev process, then your dev checks in some code, or doesn't even check it in. They write some code, pass it to a DBA, they review it. Okay, you've got a feedback loop there, and then they want to go and deploy it, so they deploy it to a development environment. And if you then have to deploy it to a test environment, you can see if you want to do this fast, it's just a big blocker. The biggest thing, though, is that the distribution of people in the organization is largely weighted in terms of a developer side. I've never seen it, probably the ratio is 1 to 20, 1 to 15, if that. So unless you've got a DBA in your team, which you can argue is a good way of doing things, having it pushed off to a team to review is just a big roadblock. And so without the roadblock, you get this continual cycle where you can write code, ship it, gets built, gets deployed, runs some tests, gives the developer the feedback, they can fix it. And so you end up with this continual process which works very quickly. And that's what you need to do from an agile perspective. Want agile, you've got to remove that roadblock. And so you've got to convince your DBA. And hopefully, if you walk away from here, you can show your DBAs. How many people have got DBAs that act as the guardians and the no people? It's like, and they don't want to be no people. But without having that process in place where you can check stuff and you can deploy it automatically and you can run performance tests, then they will be that no people, because often, being a DBA guy, devs write bad database code. Without having any testing in place, that doesn't get caught. So what about compliance? How many people are working in a compliance type environment, cardholder data, that type of stuff? How do we fit that, or sort of work out that battle? Not coming from a security background or an audit background, whenever an auditor comes in, PCI auditor, QSO, whatever, I always sort of ask them, what do they actually want? What is the purpose of the compliance? Too many auditors are from the dark ages, come from PwC, KPMG, whatever, big, sick, the classic auditor background. They don't understand this new software delivery process. They don't understand what you're trying to do. And you have to sort of actually look at what compliance is. Is it a definition of how you should do something? or is it a set of requirements? Too often, those auditors come in and they go, you need to do this like this. A friend of mine was telling me that some guys came in to review his database system, and it's like, thou shalt have foreign keys. It's like, as a team, they had made a decision. They didn't need to put foreign keys in this database because it got in the way of some of the functionality that they had. They had worked around it. They had worked out the risk of not having them. They had checks in place that actually checked the data, and so they essentially had foreign keys, or the foreign key validation, without actually having foreign keys. And this is the point about compliance is about managing risk. Yeah? It's there to sort of mitigate all those problems that you can have. So PCI is there to make sure you're not doing stupid shit. Yeah? It's all about making sure you're not doing silly things that can expose you, your customer, or even the greater good, the greater world, to problems. I mean, if you built an operating system and it meant that people could go and get into it and run bad code on it, that's bad. It doesn't affect you directly or your customer, but it can affect lots of other people. And so really, compliance is all about preventing you from doing things, detecting whether something's actually been done that's bad, and also controlling what you should do. And so from a compliance and a CI perspective, then continuous integration gives you automated testing. Automated testing gives you reduced risk. You get better quality code out of it, and so that's reducing your risk. I think one of the big things that's difficult to appreciate is the small change aspect of continuous delivery and continuous integration. If you work on making a small change and you ship that small change, you therefore have a smaller surface area that can go wrong. Therefore, you've got a smaller risk of making that change. How many people have been involved in projects where they've got like 2 months worth of work and people are frightened to push that deployment button because they don't really know exactly what's going to happen? We've all been there. We've all been on those monolith projects where back in the day someone wanted to go and make a big change, and it's like, it's a fantastic change. I mean, I've got a dev at the moment that has rewritten our provisioning process. But because he's written it in such a way, it's a massive change. It's like shifting from this thing to this thing. And he hasn't built any tests. And so what he can't do is go and he's very worried about putting this into production. So that small change thing basically reduces your risk. Small changes means quicker feedback loop. Quicker feedback loop means you can do quicker fixes. Quicker fixes means that if something does go wrong, things go wrong. Yeah? Or something always goes wrong in the world. Yeah? You can't work on a perfect system. If they go wrong, you can fix them quickly. Therefore, they all lead to reduced risk. So that's the integration part. What about delivery? Well, if you're doing automated deployments, then what that means is that you can deploy to multiple environments. Multiple environments means you can do performance testing, you can do production-like testing, you can do all these testing things that mean that you get better quality. If you're doing automated, it's repeatable. Repeatable means less problems. Less problems means lower risk. Big, big thing. If you're doing automated, you remove yourselves from that process. I'm not saying we'll make mistakes. We all make mistakes. If you look at most of the outages that occur in Azure and AWS, they occur because some human person has been involved in a process that hasn't been automated. And then final thing is that if you have a continuous process, and I'm also not saying continuous in that it's always running, but continuous in a contiguous line from checking something in to deployment, you have this great lineage. So I can see that this change, this code change, resulted in this being built, this being deployed, and this being tested. From an auditor perspective, that is just, they get so excited about that stuff. And therefore, fundamentally, continuous delivery equals reduced risk. How many people have battles with their auditors about CI and CD? Okay, a few. So I think there it's like we showed that continuous delivery helps your risk profile and helps from a compliance perspective. Azure DB. How many people are using Azure DB? SQL DB. Okay. How many people know about the V12 version of SQL DB? Okay. Very interesting. So until very recently, the past couple of months, Azure DB was this version of SQL which was very limited. They built it a couple of years ago, and it had a funky replication model to keep data in sync. That had some implications in terms of the surface area it supported. With V12, so all the servers you know, it's in preview, so it's the preview mode. The servers you now build have better management. So you have table partitioning, you have compression, you have index rebuild, you have online index rebuilds, there's a 2 gig limit before that has now been removed. You have checkpoint support. Essentially, V12 is pretty much the same as on-premise. You now have better diagnostics, so you have DMVs. You have node-level query plan DMVs. So if you're running a query, you can see what the nodes in the query plan and what they're doing. Better programmability. So one of the big issues before was you couldn't do half the things that you could do in the on-premise SQL Server. You now have all the analytic window functions. You have CLR, you have XML indexes, heaps. So you can now do heaps. Before you couldn't. So you couldn't shift your application in the cloud very easily. So it's better performance. It is essentially Enterprise Edition in the cloud. You've got in-memory. You've got parallel queries. You heard this week about in-memory and column store and parallel on column store. All those things are going to come to the cloud, to Azure DB, before they come to on-premise. Now, okay, that's great. Azure DB has got some funky features, but how does that help from a compliance and a security perspective? Well, there's now got an increased uptime. They now promise a 4 nines uptime. That's pretty impressive. You have point-in-time restore and geo-replication, so you have readable secondaries. All those great things you have on-premise, you now have in Azure DB. But better than that, Azure DB is more secure. You have the same as on-premise. You now have TDE. You have column-level encryption. User security, sign modules, all those other great things from a security perspective. It is essentially got the same security aspects as on-premise. It's actually more secure. It's more secure because you have a level of auditing, you have row-level security, which is in Azure DB now. It's coming to SQL Server 2016. Data masking, so you can essentially mask your data, so your general user can only see part of a credit card or part of a social security number or part of an address, part of a date of birth, etc. You have transparent always encryption, so the brand name is now always encryption. Firewall protection, so you can firewall off your SQL DB very easily just through the portal or through PowerShell. It's very easy to do. And encryptions of connections. By default, there is an SSL cert on Azure DB, so you can encrypt not just so with SQL Server, all connections, so the login process is encrypted so that passwords are always encrypted. However, after that, by default, your connection, your transfer of data isn't encrypted. With Azure DB, it's very easy just to click the encrypt connection because there's an SSL cert already set up on the Azure DB. So you can encrypt your data end to end. Compliance. So it's all about compliance. If you are doing PCI, so they now have, who's doing holding card data at the moment? Okay. Have you seen the new V3 PCI DSS? And are you compliant? They're already compliant with V3 of PCI DSS. Now, that is fantastic because you can just go to your auditors and for all the areas about hosting that your auditors ask, you know that you're going to be compliant. Now, this doesn't mean by default that any application you build on top of Azure or SQL DB is compliant, because you can still do stupid things and put things in the right place or hold card data, but from a hosting perspective, they are totally compliant. There's something missed off here, I was told by the security guys, so some Austrian compliance as well. So essentially, if you go to the Trust Center, you will see the complete compliance list for SQL DB in all the components within SQL. So that's great. So you get better security functions, you get the same surface area from a programmability perspective, so you've got familiarity from an on-premise to Azure. You have compliance from a hosting perspective, from the data center perspective. The biggest thing is patching. How many people can say honestly that they are patching their SQL servers every month? Hands? Every place I go into, it's like, oh, we can't patch the SQL server. It's like, that means we've got to take the system down, and it's like the dependencies. And if someone says, right, okay, someone has that concerted push, right, we're going to start patching our servers, we're going to patch our SQL servers, and it then takes 2 months to get agreement within the business that you're going to take this application offline and you're going to patch it. With Azure DB, it's done for you. Just like all the other PaaS services, patching is done for you. That means your surface area for issues is very, very limited. So, oops. We've talked about Azure DB and the fact that it's compliant and it's got a great surface area. But then your DBA will come along and go, but it's not possible. We can't do it. You can't deploy this because this feature's not supported or that feature's not supported. And my big thing is that with the code today and the environments today and the tools available, you can really do anything. So SSDT is the piece for doing deployments for databases. So you start off with a set of schema files, and how many people are doing desired state configuration for PowerShell and anything else? Okay. So I find it interesting that desired state configuration is this sort of new nirvana for configuring infrastructure. You say, I want my environment to look like this, and DSC will go and make your environment look like this. SSDT database projects have been doing this for 10 years. Essentially what happens is you take all your files, you'll create table statements, and you build it together into a gold version. And that gold version is a schema. And what then happens is at deployment time, there is an engine. So DACFX is the engine. DACFX will go and extract the schema from the database that you want to deploy to, and then figure out what those changes are that you need to apply to your database, and make the change. And then your database is all upgraded and great. So how many people have used SSDT? A few. Okay. So I'm sure you'll appreciate that reality is a little different. Yeah, reality is more like this. You actually need a pre-script. So a pre-script is a script that runs before the DACFX process runs. And that can do a few things that isn't possible in the DACFX process. What you then have is your process extracts the model and goes and generates your update script. And then from a deployment perspective, you have a pre-script which goes and sets some things up, potentially insert some records so that you can keep track of things through your deployment. You then run your upgrade, and then the big gotcha-all or catch-all is the post-deployment script. And the post-deployment script can do things that clean up objects, go and set things up that aren't possible within the normal DACFX SSDT process. And so that's what we're going to look at today. So let's get on and have a look at our database. If it hasn't fallen asleep. So what we should find is that our release has gone and been released. Cross fingers. Oh, it's set to approval. So what I've done is in my path, I've actually set my approval process so it doesn't get deployed to production until I approve it. So let's approve it. You can put a comment in. Oh, if I can spell. And what this will now do is take the process into the next step. And so this is now deploying onto my production database. And if we go to Management Studio, I should find my test dev database exists, and that doesn't exist yet as it's going off and doing a deployment. So what I want to change next is this application is actually by, I'm sure you saw what the table name was, this is holding card data. And what we're going to do is use some of the new features in Azure DB, which does column level encryption. But what I want to do is do this in a way that is sort of transparent to my application. Let's see if this is finished. So what I want to do is I have my card table and I need to go and make those card numbers encrypted. And the way I'm going to do that is I'm going to refactor my card table into another table called card encrypted. So I'm going to just switch onto a middle branch which has got my changes. And what we'll see is that my card encrypted table looks very much like my card table, It's got the old columns, but I've also added some additional columns. And these additional columns allow me to gradually encrypt my data so that I can make my deployment and then over time backfill and re-encrypt all the data that I have. Therefore, I have refactored this table because when I do my deployment, I don't want to lose the data I already have. So if I had just created another table called card encrypted, how does it know that it needs to rename it as opposed to just create a table called card encrypted? In VS, you have this refactoring, which enables you to rename. That is logged in a refactor log. And so you can see here that I've refactored this table called card to called card encrypted. So what this will do is when the deployment process looks and finds that table called card in the database already, it knows it needs to rename it to card encrypted so I don't lose the data. So let's just see if this is finished yet. In progress. There seems to be about a 1 minute 20 overhead in terms of Release Manager running a remote PowerShell session to do the deployment. What I also need to do is I need to change if I want my application to continue, my application is doing inserts and selects from card. So what I do is essentially replace card and make card a view onto the card encrypted table. Now to make this actually work, I need to do this in a number of steps. And this is one of the big things about the impossible that you need to take away, is that, okay, going from here to here in one step probably is impossible without bringing your system down. But if you break it into chunks, into small chunks, then you can make those changes in a way that make it possible. So what we're doing is we're going to create this view which points at the card encrypted data. And by standard behavior in SQL Server, you can still insert into a view that points at a table. It'll just do that insert and update and delete direct into that table. Do we have a deployment done? Not. Yes, finally. So here is my little app. This is my little PCI card inserting app. And what this does is this goes off and it's not V2 yet. Let's get rid of those errors. This goes off and just generates a card number and inserts it into the database. What it also does is it does a select from the database on that card number to go and verify that it's been inserted correctly. And so that's just carrying on and going away. What I now need to do is do my change. So let's go back to Visual Studio. Let's go and make a change. Put another comment. And push that change. And then go and sync the change. How many people are using Git? Make the move. It's worthwhile. So this will go on and set up another build. So we have our middle build. So let's go and have a look at what Release Manager is doing for us. Anybody using Release Manager? A few people? Okay. So Release Manager in 2013 is okay-ish. It has a few quirks. In 2015, the whole build system process is changing dramatically, so it's a lot better. But you can still achieve what you want to do from a compliance perspective with Release Manager, which largely is about controlling how you push to production. And I think that's the biggest fear that a lot of people have with releases and the whole CI/CD process is they believe that it means that a dev can go and write a change and it be in production in 10 seconds. Well, it could if you want, But if you're in a compliance world where someone else has to go and make sure that tests have run, etc., then RM really fits in that gap, or achieves that as well. So for those of you that haven't used Release Manager, let's go and, what you do is you define some paths. And your paths define which stages you've got in your deployment process. So in this example, what we've got is we've got a dev stage and a production stage. And one of the nuances is that Release Manager in its guise currently, in 2013, works with environments. And environments are a set of servers, but I'm deploying to Azure DB, which isn't a server, it's a PaaS offering, it's a platform as a service offering. So how do I actually do my deployment? So you have to do a bit of a jiggery-pokery in that you have to create a VM, which is an agent, which is where your deployment runs and makes the deployment onto your PaaS offering. Additionally, what you have to have is one agent per deployment. Currently, what you have to do is, if you've got to do multiple deployments at the same time, you have to have multiple agents. That's just one of the things you've got to do. But spinning up, one of the nice things you've got, and I'll show you in a minute, is that you can have the release bring up and bring down those deployment environments during the release process. So from an Azure perspective, it becomes almost cost zero because they're only up there for the duration of doing the deployment. So this is our stage, and within each stage there's a number of steps, and you can decide whether they're automated or not. And then once something is finished in a stage, you can say whether that stage, the build, the release, carries on to the next stage automatically or via approval. So here I had approval set, and so that meant I have to go and approve it. So if we look at releases, then what I should find is my middle release that I've just pushed through has got to the approve stage, so I can approve it. And then that will carry on to my production release. So once you've defined your paths, i.e. where your environments are going through, what you can define is you have to say how you're actually going to do those deployments for each of those stages for each of your applications. So I have my release template here, which is looking at my middle branch. So just for demo purposes, I've got 3 branches to make it simple from a code perspective. This is my environment here, which is my agent, my pseudo stepping point to do my deployment. And this is the component that I've said I want to deploy. And you can add more components, and when you add a component, you can say whether it's built as part of this. So you tie a release to a build in TFS, and you can say whether the component is built as part of that, which means it's in the drop location for that build, or you can say it gets built by something else, in which case it will go and Release Manager will go and pull the artifacts from the drop location for that component into the release. I'm using vNext environments in Azure, which means that the only options you've got for tasks, so whilst this is XAML, it's very simple. I'm using deploy using PowerShell/DSC, which means that you pass in a PowerShell script, which is either a PowerShell script or a DSC PowerShell script. So I'm doing a PowerShell script, and then a set of parameters, variables. And those variables just become set as standard PowerShell variables, which you can then use in your PowerShell script. So if we go back to the release, my app has stopped. That's probably because it's just been delayed while the release went through to production. So that has, oh, it's still pending, okay. So we'll leave that going. And what we'll do is we'll go on to do the next change. So that change is going through my system and is going to get to production very shortly. So what we've done is we've taken our card table, we've replaced the view, we've refactored it and put a view on top. Now what we need to do is actually encrypt the data. And so we're going to encrypt the data by going off and using a trigger on that view. So let's go to my final repo, final branch. And what we'll see is in our card table, our card file, what we are actually doing is using these encrypt by key functions, which are the column level encryption functions which are now new to Azure. And we are passing in the certificate that we want to use to, so key management, you have a data encryption key and a key encryption key. So our certificate here, credit card, is our key encryption key. This credit card is actually the data encryption key, and so you can only open this if you've got access to the certificate. And so this will, instead of inserting into the table, we'll go and insert using encryption. And it sets the encryption type to S, which then means that in my view, I can do a case statement which says if it's actually encrypted with S, i.e. SQL, then decrypt it, otherwise use the card number. So this means that at a point, we will have data that's not encrypted. So if we go and push this change, into my branch, and go off and look at my build is going ahead. And what I should find is that my release is now, so my release is finished, hopefully. So that's been released. My app has been carrying on going. Now what I can do is, I told about stages. So because this app goes off and queries for the card number to see whether it exists or not, what happens when you encrypt that data? What happens from a query plan perspective if I want to go and find out whether that card exists in the database when that card number is now encrypted? Any ideas? Pardon? It won't find it, is one thing. The other aspect is that my card, I could go and decrypt all my cards and see if it matches, but that means I've got to scan through my whole table, decrypt them all, and find out if it exists. That's going to be jolly expensive. CPU expensive, I/O of reading all the data expensive. So what we're doing to make this work in stages is we're adding a card mask. You're allowed to store the card mask and the encrypted value, and therefore we can do a sort of pre-filter on rows that match a card mask, and then only decrypt those rows that match the card mask. And therefore, we're only selecting a few rows and then decrypting it. But to do that, I've had to go and make the app change to go and say not only look for the card number, but include the card mask. So my version 2 of my application, I've got a feature flag which I just enable, which is now going off and using the card mask as well. If I didn't do this, it would run very slowly when it's doing the insert. So if we go and refresh my release manager, I should find I've got a new release in progress, and it's deploying currently to my dev environment. So let's go and look at what the deployment is actually doing. So the deployment in this situation is a PowerShell script. Move this around. And for debugging, I'm writing out the parameters that are being set in the build, and then going off at the end and calling SQL package with a set of parameters. Now, how do those parameters get set? Well, there's a couple of things. If we go and look at the release process, and look at production, whenever you create a certificate, you need to pass some information to go and create that certificate. Now, in dev, I can just use a test certificate. I don't need to do huge duality in terms of having two people build my certificate. And so in dev, I'm just using default values. So I'm not setting any values for my certificate properties. But in production, I am. And this is one of the very nice things about Release Manager, is that I'm able to go and set some of these values, but they're all nicely encrypted and not visible. So one of the challenges about PCI is you're supposed to have duality in terms of having two people, not one person know the components that make up your certificates and your keys. With this, you can have one person go and put in one value, one part of it, another person put in another value. Those then get set to PowerShell values in the deployment. The PowerShell, our deploy PowerShell script goes off and passes them to SQL package. SQL package has variables which in my project, let's just minimize that, are defined as variables. So these are variables which allows me to then use them in my scripts. So if I look at my security file, what I'm doing is I have a stored procedure which takes all the components to go and build my keys and my certificates. It also actually builds my views and my stored procedures because I need to, if I want to do key rotation, I need to go and include those within my view and my triggers. So all these are passed in, and within my script, I'm then, so how do they get to the stored procedure? Well, there's a post-deployment script which calls create keys and certs, and create keys and certs calls the stored procedure and passes in these parameters based off the variables that are coming in from the SQL package deployment. So you can see how you can push sensitive data through your pipeline into your deployment, into your database without any of your developers being involved. You don't have to store these in your source code. Hands up who's got passwords in source control. Own up. Everyone's got them somewhere. This is a very nice way of solving that. So if we go off and look at my application is still running. Let's see where my release has got to. So it's got to the approve stage. So if we go and approve it, that's going off and approving, and we'll go on to the next stage. If we look at our process, some things that I've included, and this helps your compliance from a traceability perspective. Let's go and change my database. Is I've got a standard process in my build which takes all those values, those parameters, and not the sensitive ones, of course, and stores a nice XML blob. So this is actually using sparse columns and allows me to go and see it was deployed using a stage, this was the name of the release, this was the agent that made the release, this was the IP address of the agent, So I've got full traceability from a database perspective to see which release actually made this change to this database. So let's have a look to see if our database has been encrypted yet. So it's still running through. Now, one of the other aspects about database deployments is the fact that you invariably have to do some level of data movement. And one of the things that we do in this process is we need to go and re-encrypt the data. And so you will have seen in the post-deployment script a call to backfill. So backfill is a standard process that it's not standard, it's a standard step that you would have in your database deployments. And what we do in this one is we call a set of stored procedures. Now, a lot of people write a post-deployment script, which is just a set of SQL at this point. I'm really against that, and I'm actually in favor of any of your post-deployment scripts aren't actually scripts, they're just calls to store procedures. And the big reason for that is your post-deployment scripts don't get compile validation. So if you've got column names that are wrong and those sorts of things, table names that are wrong, they don't get validated until you actually run them, which is a bit of a pain. So if you create a stored procedure, the stored procedure gives you nice compile time validation. And that's one of the big things about SSDT is that compile time validation. I go and make a change to a table, change a column name, I immediately know all those stored procedures, all those views that have broken. So this backfill does another pattern that I recommend is if you just go and update your table blindly without any sort of process, you'll end up blocking your application. You'll end up with key escalation, which means that it'll start off locking individual rows. Once it gets above 1,500 locks, it will go and escalate and lock the whole table. Locking the whole table then means that your application won't run. So what you can do is, in your script, is do it in chunks. So what this does is update our card encrypted and sets the card mask to the card mask that we need to use between the two different card ID values, so with 1,000. So this is going to do 1,000 rows at a time. Now the important thing is that if you use the primary key, the clustered key, what it does is it will only lock those 1,000 rows. If you don't do this based off, so often people forget this and do update top 1,000 without the card ID bit. Now what happens with that is that the first time it runs, there aren't any that have got a non-null value, and so it finds 1,000. The next time it runs, it's got to scan through those first 1,000 and then find the next 1,000. And by the time you get to the end, it's having to scan through the whole table to get the 1,000 records that haven't been updated yet. So it's really, really expensive, and you end up with this sort of exponential process by which it's very slow. By doing it based off the primary key, off the clustered index key, you end up taking 1,000, 1,000, and each update should take pretty much the same amount of time, and you shouldn't end up with any blocking. And you can make it in small enough chunks that that update is in and out within milliseconds, and it's not going to have any impact on your application. So with that, we should see that this has released. Touch wood. That is done. And if we look at our table, what you can see here is we've just got some binary values for our cards. So you can see that our cards are now not being set in the card number, but are being encrypted. But importantly, what you can see is that the application has carried on running. We're not getting any errors. It's still validating. So it's transparent to that application the fairly big refactor change that we've done. Any questions on that? Right. So what we've just done is we've enabled column level encryption, which is a fairly big refactor change. We started off with a table. We changed the table to be, we refactored the name of it to be card encrypted. We stuck a view on top. We then went and added some extra columns. We want to do that in a way that doesn't block inserts. Now, interestingly, there's actually some changes within SQL Azure that there are more online operations. So historically, if you go and add a fixed width data type column to a table like int, date, times, it has to go and add that value onto every single row on every single row in the table. And that becomes a very onerous process. Now, in Azure, there's more operations which they're just metadata operations. So they're almost immediate. And SQL Server internally knows whether this has actually been set or not. The next time you do an insert, it will then go and populate it. So that's great from a deployment and an online deployment process. After we've added those columns, to actually encrypt the data, we need to put that view, make that view go and read the data and unencrypt it, and also have that instead of trigger that goes and does the deployment, goes and gets the key and gets the certificate, does the encryption, inserts the data into the table, and then the view can then read it correctly. And then finally, we need to backfill and re-encrypt that data. And we need to do that in a way which isn't going to block the deployment. Now, how many people are using Entity Framework? Okay, a few. So I'm a big fan of Entity Framework and the data migration piece because it actually moves the ownership of that data migration piece into the application. However, you're very limited in terms of what you're going to do. With this, you've got much more control about how you're going to do that data migration piece. So really, what I hope you got away from here is that SSDT and database deployments, pretty much anything is possible. We did a fairly big thing. Now, the one thing I didn't tell you is that, so column level encryption was only enabled in Azure about 2 weeks ago. Unsurprisingly, the tooling for SSDT doesn't support column level encryption. However, I've still been able, using SSDT and the whole deployment framework, to deploy and make my change. Using that model I was talking about pre-deployments, pre-scripts, and post-deployment scripts, I'm able to achieve what I want to do. So in summary, Azure DB is equal to on-premise in terms of functionality. There's about 3 things that aren't there. So full text is there, service broker isn't there, unsafe and external CLR, and I think that's about it. Everything else is there. Link server's not there. That's very true. Well spotted. Most things. I'd say link servers are evil, but that's like a second. We'll discuss that later. And with SSDT, you can really manage any deployment, and even things that really aren't supported. That's the great thing about the power of the tools we've got. So therefore, Azure and SQL database with CI and CD really gives you that strong compliance story. Sticking that combined with Release Manager gives you that end-to-end lineage, and you can really say, yeah, this change was done by this check-in, this build, we tested it, it was approved by Bob, it was approved at this point by Fred, and that should meet all your auditors' need. So don't fear this change, and don't fear the impossible, and embrace it. Some resources, the Trust Center, SQL Server Data Tools, Release Manager, and my contact details. Any questions? Right. Stunned you, silence. Well, feel free to come and ask me now, tweet me, email me. I'm around for the next 2 days. I'm in the UK, so it's a bit of a long distance to come and see me, but feel free to drop me a line at any time. So thank you very much.